Minneapolis or something like that, they wouldn't really be the effect of an extreme weather event in San Diego. And you might think that the effect might be different there, but at this point you just can't. So what we say is outside the support of your data. Like you don't observe any days like that in San Diego. You can't be sure exactly what that effect would be.
So what's the point of including San Diego?
So in theory, that's a good question. Basically, there's very little value to doing so. In theory, it can help you sort of pin down like the coefficient estimates on some of the other control variables that you might have in there. And in theory, sort of on like a very sort of second order thing, it might help a little bit with your standard errors. But basically, you could think that dropping it out is not going to change your estimates very much, one way or the other. So what they find when they run this first specification that has all the like month by county fixed effects or month by county indicators in it is that cold days are associated with essentially no mortality change for females, but a 1.4% increase in mortality for males. And then hot days are associated with a 3 to 5% mortality increase for females and a 2 to 4% mortality increase for males. So it seems like the days that are really sort of bad here are the hot days. So let's see. So then the next thing I'm going to talk about is accounting for sort of the longer lag structure of the potential effects. So essentially it's like looking at whether or not there seems to be some harvesting going on. And that will reverse the conclusion. But first, let me pass out. So I want you guys to sort of think about just this true-false type question. So for each group, I think I have like a couple of these. I mean, they're all the same, but just sort of like you can have like multiple people looking at it at once. Your guys are group 2 or 3.
These numbers are statistically significant.
The 3 to 5 and the 2 to 4 definitely are. I forget if the like 1.4% is. So this is sort of like a true-false question. So I just want you guys to talk about it for a few minutes, decide whether you think it's true or false, and then on the back of one of the 2 sheets that I gave each of the groups, write down like true or false, write down like brief explanation for what you think, and you cannot exceed the amount of room that's on the back of this, and then write down your group number and the people who are here today. Okay, you should write your answer down now, and then I'll collect it shortly. Yeah, you should write down an explanation. But it cannot exceed the back of the thing. Guys ready? You have to write your group number and people who are here. You guys ready? Sure. You're not ready? Okay, this is going to be problematic. Okay, write down what you got. And don't forget to put your group name and numbers on it. Well, if you have the names, then I know who it is. Well, I want to know who's actually here today, but thanks. You guys ready? Yeah, but it's okay if you don't have one. Just turn it in. We just have to go now. So, okay, that's fine. Yeah, you can just write that. It's fine. Got it. Group 5. Oh, okay, sure. You guys ready? So 5, who else do I not have? Oh, you guys. You don't need the first name, it's fine. Thanks. Okay, so is there a group that wants to discuss their explanation for like guaranteed credit? Okay, group 6, because you guys I think are still in last place, so we're very progressive, like that.
From the calls, it was like we weren't really sure whether our exercise was connected seasonally, because like some people who are healthy will work out in winter, and then people that are unhealthy won't work out during the summer.
Mm-hmm.
Also, like a lot of people will start working out like January for New Year's resolutions.
Right. Right. Okay, so you guys are basically sort of saying, look, this is theoretically possible, but it doesn't really seem that plausible to us. Okay, so which I think is probably true. Like, I don't think this is a very plausible scenario. That being said, this question is kind of tricky. In fact, I mean, I think you said on a problem set or something like that, and then I kind of took it off because people are like, oh man, this is like too tricky. So I won't be surprised if people don't get the exact answer that I was looking for. Does any other group want to? I guess there's another group that's something that had a different rationale that wants to discuss it. So you guys are 4 or no? You're okay, 2.
So we said uncertain because it might be exercise might be like a correlated variable. There's so many other correlated variables that might be associated with that as well. So we just assume that alone won't be like, I guess like you can't really say given.
Okay, and then group 4, what were you guys thinking?
Okay, like I just thought about it, but if you indeed include the exercise amount of exercise element in there, that might be confounding with age, because younger people will exercise more. If you're not controlling for age already, then you're including that in your estimate of exercise with, like, and then it's going to bias your estimates.
Well, so I definitely agree that age is going to be correlated with whether or not you exercise and with mortality. In this particular case, though, I mean, age is not going to be correlated with seasonality because, like, I mean, except insofar as maybe people are slightly older in winter than summer, depending on when you start to start time. But it probably won't be a major, like, there probably won't be a large correlation between it being winter and people being older and it being summer and people being older.
Exercise is also like getting out doing things and also cause mortality. So if you're going to take into account like the adverse effects of being stationary, you also have to take into account a lot like the raise mortality of actually being active in summers.
Right. Raise mortality being active during summer.
Like
from other.
Like,
Right.
Drive more in the summer.
Right.
There's lots of other like, causes that.
Yeah. So I mean, I think there are like a lot of potential seasonal confounders that could essentially like drive some of the seasonal patterns that you're seeing. So my answer for this question is false. But it's not quite for the reasons that you guys are thinking, which is fine because we didn't really discuss this in class. And I kind of want to discuss it now because I think it's something that we should talk about, but I also don't want to like put it on an exam because it is kind of like somewhat tricky. So like all of you guys are actually sort of thinking along the way that I want you to think, which is like, oh, is there going to be a potential correlation between like seasonality and exercise, and then is there a potential correlation between like exercise and mortality here? And because if those two things hold, then that's sort of something that we think we need to control for. And usually that's the correct sort of rule of thumb. The one thing that's different here though is the way the question is stated. It actually says that, or the sort of scenario is laying out is that the weather itself has a causal effect on exercise, which itself then has a causal effect on the outcome, which is mortality. So it turns out if there's another variable that is not just correlated with the treatment you're interested in, so remember here the quote-unquote treatment is like cold weather or warm weather. So if there's another variable that's not just correlated with that, but is actually being causally like changed by that treatment, then you don't want to control for that other variable. And the reason is that you can end up sort of over-controlling for things. And I think the best way to demonstrate this is to think about this like regression that I wrote up on board here while you guys were talking, which is that you could have a regression model in which longevity, so like you have data on people, and how long they live is a factor, or is affected both by, first of all, whether or not they smoke. So we know that like smoking is bad for your health. You tend to live shorter, so beta 1 is going to be negative there. And it's also affected, of course, let's say by whether or not you get lung cancer. And obviously lung cancer is very bad for your health. It's going to severely reduce your longevity. And of course it's correlated with smoking because we know that smoking is like the primary factor that causes lung cancer. So you could run this regression. And the way you interpret beta 1 here, so you'd be like, okay, well, I know from class that if this other variable is correlated with smoking, and if it's correlated with the outcome, then it's something I need to control for, right? And normally that's true, unless it's the case that this other variable is actually being causally affected by the treatment itself. So here the treatment you're interested in is smoking, and you want to know how many years on average does like smoking take off your life. But when you run this regression, you're basically saying, I want to know how many years on average smoking takes off my life if I control for the fact that smoking causes lung cancer. So it's sort of saying like, well, if I kind of ignore the fact that smoking causes lung cancer, then how many years does it take off my life for other reasons? And maybe there's some cases in which you might be interested in that question, but in general, what you're going to be like really interested in is how many years overall does smoking take off your life. And if some of those years are coming off because smoking is causing lung cancer, you don't want to sort of control for that fact and say, well, I don't want that to sort of count towards the years of life lost from smoking. So it's actually, if you think about carefully, the scenario in this situation here that I posited is actually the same. The idea is like, when it gets colder, then you stop exercising, and exercising has this causal effect on whether or not, so that to be clear, there's a causal effect of it being colder on whether or not you exercise, so you don't want to go out when it's cold, and then exercise itself has a causal effect on mortality, and so you're sort of controlling for this thing that's actually being causally affected by the treatment. In that case, you're basically over-controlling, and you're going to end up with sort of too small an estimate relative to what you would actually want to be classifying as the entire causal effect. So again, this is kind of tricky. It's not something we really discussed, so it's not going to show up on the exam. But there are cases in which you don't actually want to put in additional control because it's being affected by the treatment itself. So we'll finish talking about the study on Wednesday.